Now we are going to design a shell like this. The big difference with the previous shell is that the previous profiles were designed in levels, but for this shell, we need to design the profiles in elevations and on the reference planes. So we need to have as many RPs. We need to design as many reference planes. Now, for designing reference planes, we've got two methods. The first one is to design it in plan. For example, I go to level 1. Let's just imagine we need 4 reference planes. So I click on RP, I pick a reference plane, and I start designing, which I believe is the best way. There's no risk in it. Or we can do it in 3D. We can just select the work plane and then draw the reference plane here. But a common mistake being made by many people is that, for example, one of the RPs is already set. You were doing something and it was set, and you're not careful with it. You pick reference plane and we're not careful. We don't know that elevation reference plane has been set as the work plane, and we draw. So you see that this has actually been drawn in this work plane, and it's giving us actually a horizontal plane. So be careful when you are drawing the reference plane. You should have already selected the level. So I tell you that why should we take this risk? You can always draw them in plan so that you don't make this mistake, right? So we go to the 3D and we want to start modeling. We've got 4 reference planes. The first one is the default, and we design 3 here. Now, to be able to set our reference planes, what should we do for that? One way is to go to plan, like before, and then click on set, pick a plane, and okay. Click on it, and then select one of the elevations, for example, east or west, like before. We had it. We already know it. It's good. It's not bad, right? And we can, of course, go to 3D too and set them. I told you that how the reference plane are set. Do you remember? I said that when you select them in mass, of course, they are just selected. If you actually, yeah. Now, you might wonder why these RPs are up here, are at the top. Well, don't make this mistake. RP is an infinite line, right? And this line is just the representative of that RP. And it doesn't matter in what height it's placed. It's just a plane, as you see. It's just a plane which is completely infinite. So I select this, it's set. Now I want to design it in this elevation, so I get help from this cube. I'll click on it and I enter the elevation, and now I can start designing. So for example, I pick line and I draw something like this. Now let's go for the second one. I select it, set it, it's set actually, line, and I draw it. As you see. Now I want to go for the third one. And you see the dots that sometimes they appear, sometimes they don't. It's a graphical thing that sometimes Revit, when it doesn't match the graphic card, they are not here, they are sometimes here. And sometimes I just close my Revit and then open it again, and it will be okay. Well, let me draw the third one and I'll tell you the point. So I select it and I pick this. When I start designing the third one, see what happens? It recognizes it. And you see, again, it recognizes it. What's happened? When I rotate, I see that it has left its own plane and it has jumped on the previous lines. Now, why did this happen? And why did the lines leave their own plane? Can we control this? That's right, it's got an option which we are going to analyze now. Let me undo. So the third plane is set, and then I go to the elevation. So you see that sometimes this happens is because of the graphic. When you wireframe, for example, it's definitely corrected now. So I picked line. As you see, when I actually move my mouse on the lines, it detects them. While we're drawing, we've got two icons here, which we can control these with. The first one is draw on face. In this mode, your mouse, right? If your mouse is on any line or any face, it will detect it and it will jump on it. So now these lines are detected and it's jumped on it. So what should we do for it not to have anything to do with other objects and does not leave its own plane? So we can use the second one. You see it says draw on work plane. Well, it's clear by the name. It just draws or remains on the work plane of its own. So when it's this mode, you see that it doesn't highlight it. You see that? It has nothing to do with these anymore. In result, it remains in its own work plane, but there's an exception. Now, for example, it's not detecting these. What's the detection? What's the exception? When it snaps on the dots, again, it will leave its own work plane. And if you don't want this to happen either, you need to turn off your snap, right? It means while you're drawing here, well, it doesn't, it actually, you see, it will recognize that. So with SO shortcut, you see, you turn off your snap so that it does not recognize that one either, and you will be able to draw. You learn the points about these two icons, don't forget. So I draw this too, the third one. I set it, and I go to the elevation. Pick this up too, and the design. Now graphic card is actually being helpful. It's not making any problems. If you see it doesn't show the dots, if you just close it, close the program and open it again, it will be all right. If you see that the number of these lines are, there are a lot of them, and you don't want to select one by one, you can just open a box, select everything there, and then use filter to separate them. Amongst the list, just line match, just select that. We don't want reference lines, reference points, none of them. And then click on create. I shade it, and now we have our shell. And as you can see, all the art is actually shows itself when we design lines, because when we just click on create, we create it at the moment. But let me tell you something about creating the shells. For example, I'll go to level 1. I designed a shape, and now I wanted it to be a void. So I select it, move it up, and now what should I do? I need to use cut. That's right. I need to cut it. Select both void and the shell. Now, did it cut our shell? Yes, it did. But what happened? The void remains. So don't care about this, that the void remains. When we load this into our project, now we don't have an open project. When we load it into our project, it will be moved correctly as, a shell that has a void. Well, as I said, blend, which is blending profiles to each other, right? Both closed and open, is the most important modeling technique in maths. which has two parts. The forms that are in a height, like a tower, for example. And I told you that we drew the profiles in levels. And the other one was actually, the other ones were shells that are on the ground like this. You see that? It's on the ground. So these kinds of forms, you should draw their profiles in reference planes, and we will practice together again and again. Don't worry. But now, editing the shells. The things you can change about shells. What are they? And well, by editing, I don't mean that you just take this and move it. No, main editings. So, number one, edit profile. Well, each shell or each form is made of some profiles, right? It's had some profiles that we can edit those profiles. For example, when I move my mouse here, you see that the profiles are shown to me. I can select them and then click on edit profile here. It's given to me and I can select it and edit it, or even delete, and I start designing again. Or for example, this one, when I move my mouse, it's given to me. I can select them, click on the edit profile, and for example, I just want to delete this. Let's design in level 3. It makes more sense. For example, instead of circle, I want to design something else like that. In this way, I can edit these. Or what I can do is to select the shell itself, then click on the edit profile, and then I go for the profiles. You see that? I actually select the body of that form, click on edit profile, and then I move my mouse, find the profiles and edit them. So at first we can select the profiles and then click on edit profile, or we can click on edit profile first and then go for the profiles. Well, you might say selecting profiles, or basically finding profiles, is a bit difficult. Well, yes, it is. So if you select your shell and then click on X-ray, you will see the X-ray of the shell. So definitely you will be able to see the profiles, and there's a line here which is the path that connects the profiles together to each other. So you can easily select them, or select your shell and then click on edit profile and then go for the profiles. And when you are done editing, you can select your shell again and then click on X-ray and it will be inactivated, just like that. Well, let me tell you an example on a cube. I want to tell you a point, right? So I draw a rectangle here and then click on create form. Now, if you select the top surface of this, you can see the edit profile and you will be able to edit it. For example, scale, anything. And of course, the same thing for the bottom surface. You can edit that too. It's got a profile. Now, you might imagine that if I select the side surface, I can use edit profile too. But when you click on it, you see nothing happens. Why? Pay attention that edit profile actually edits the profiles that have made this cube. Now, the direction that this cube was made was from bottom to top. Well, the direction that it was made based on was just bottom and top. Therefore, you can just edit the bottom and the top. So, but if you had drawn this cube on this reference plane, for example, you see that I just drew it on this reference plane. Now, can I edit the one at the top? Can I? No, I can't do that. Why? Because now it's based on left to right. And when I click on X-ray, I can even see it. I can see the direction that it was created based on. So when I click this side, I can get the edit profile. I gave you this example for you to know the policy of edit profile. It's based on the profiles that it was created based on. Keep this in your mind. It's important. So important. Let's go for the next point. The next edit, of course. The next edit is called add profile. Select the shell. Here we've got add profile. What does add profile do? Well, it's simple. It adds profile in the direction of those main profiles that the form was created based on. Let me click on the X-ray again for you to see. You see these profiles are in this direction, not that direction. So if I click on add profile, you see that in this direction I can add profiles. For example, I want to add something here. But what can the functions be? Right? After adding a profile, we can edit it. We can select it, for example, and move it. You see that here my actually axis is local. I can click on space and move it up. Now, the new profile that was added helped me to be able to change the form of my shell. Or I can, of course, click on the edit profile and edit the form. Also remember that the profile that is added using add profile has no dots or spots, right? Now, to be able to move the profiles with the exact distance or size, you can select them and then, for example, go to the elevation and then click on view and specify the distance. When we are using arrows, it doesn't mean that we can't be accurate about it. No, we can. For example, for this one, I select my shell, click on add profile. Now, how does it add here? See that? Based on the main profiles. You can, of course, select it, X-ray. For example, you want to add something here too. I add something here. After adding, I can move it, or I can click on the edit and then change the form generally. For example, I want to use a scale, anything, right? Make a change in the form. Let's see the cubes. Now, I expect you to answer me smartly. If I select this shell and then click on add profile, this is the one that was based on from bottom to top. How is the profile added now? That's right, the same direction. When you add it here, you can select it and then change it like this. What about this one? How is it added? Do you remember the direction? This is the direction, so it's based on that. Now, let's go through a few interesting points on these cubes. Now, here we added a profile, right? So here what you can do is click on tab a couple of times, select it, and without even clicking on the edit profile, you can scale it. All right, you see that? Now it gives you a very, very useful form. Or I can actually select it, just move it. Another example, let's say we've got a basic simple circle here. Very easy. We create it. I wanted it to be like that. Then I drag it up. Then I add profile here. And then I want to see the X-ray so that I can see it better. Tab, select. Then you see scale. I have created a very good form now. Sometimes even we can use this in the process of designing. We can add profile, we can remove profile, even we can move it up or down to change the form again. That's why actually it's called conceptual mass. You can actually give ideas. The next option is add edge. What this does is exactly the opposite of add profile. What does it mean? Actually, exactly the opposite of the direction of those main profiles. It doesn't just create profiles, it cuts your shell. When you click on add edge, and then you see that it cuts your shell. Check it out again. You see that? It's exactly the opposite of the direction of the main profiles. And when you click, it cuts it. You see? It cannot be so useful because it actually messes the geometry of our project up. You see, it's destroying the curve. Sometimes when it gives you delete error, it doesn't it no longer has that good angle. The function can be, for example, turning the shell into pieces so that we can have different materials or different thickness. But since it's destroying the curve, it cannot be much useful. Let me tell you a point about add edge on this cube. When you select this and then click on add edge, you see when you hold your mouse on the edges, you can click. And then with the next click, you see that? With the next click, in this way you can design a line with, of course, with a specific design. Let me tell you again, one click here, another click here. Now you can, well, obviously move this line. Well, to be honest with you, in broken actually shells and cubic, it can maybe, yes, create a design, but in other shells, no. For example, on this shell, what does add edge want to do here? What could it do? For example, I do this. You see that? It cannot be that useful, can it? For example, here. Well, it didn't work, did it? I tried again. You see that? Well, it's true that the line is slanted, but in general, it does not seem to be useful. Well, let's go for the next item. Let me undo this. And then for the next item, it's called dissolve. What does it do? Well, dissolve deletes the shell, right? And it keeps the lines, the profiles that we designed the shell with. So you might ask yourself, why would we do that? Why would we have a tool for this? Right? So, well, first of all, when you select your shell, it's not deleted. It's true that the delete is activated, but it's not deleted. Do you remember I told you a point that when you want to delete a shell, if it's not possible, what you should do? Do you remember that? I told you either you need to open a box like this, delete it like this, or what were you about to do? That's right, you were about to hold your mouse on it, tap, and then click. Right? Well, in there, it had two pieces. Do you remember that, shape? Now, you might have wondered that because it had two pieces, we had to tap. But here, it's got one piece, and sometimes you see that we have to tap and then delete. Let me tell you a point. When you just select the shell, those profiles cannot be seen. But when I tap and then click, you see that I can see the profiles, and apparently those are selected too. So now after we select our shell, you see that the lines are as well deleted with it. So we come to this conclusion that we cannot delete a shell with the profiles remained. Therefore, right now we find this tool useful. As you see, we deleted the shell, but the profiles remained. You might also wonder the function, that why would we even destroy or delete a shell? Well, let me tell you something. If you want to, for example, continue this shell, let me go to the plan. For example, we want to add another profile. So I pick a reference plane. For example, I want to design another one here, right? So I select it, go to the elevation, I pick line. Don't forget, if you use this, it will actually, it will be messed up. Other objects and lines will recognize it and it will be messed up. So you're going to have to use the other icon. So I designed this, for example. Now, if I select this, and then I select this line. Now, do we get a good show? Well, definitely not. So what should we do to make it even? Well, obviously we need to select all the profiles at the same time. So we need to select this, dissolve it. Then again, select all the profiles, use filter, keep the lines, and then create a form. Here we have it, and right now we can have an even form, and it's so functional. This tool is so functional in this situation. Now let's go for simulating revolve. Well, why do I say simulation? Because we don't have a command to be called revolve or blend. And because I want you to, group these so that you can differentiate these and recognize them, I tell you, for example, this is a simulation of revolve. So I select a reference plane to set it, and then I go to elevation. So, for example, I draw this form as a profile, right? The profile you design can be open or closed. I start with open and I will tell you the points one by one. What else do we need for revolve? We need an axis. So I design it, for example, this, right? Now, one form, one axis. So now I select the form and the axis, and then I create form. Now we have the conditions for revolve. So it detects that this axis must be rotated all around this axis. This form must be rotated around this axis. And of course, because there was distance, we have a hole in the middle. Well, revolve is the only form in mass that when it's created, it's got parameters. I mean, when you select it, here you can change the parameters. For example, here we've got end angle. So for example, if you change it to 180, you see that this happens. You can change the start and the end angle, both. Now, how can you edit it? When you design the shape, how can you edit it? Well, we saw the previous command's edit. It had edit profiles and until the end. Now, if you select your shell, any part of it, doesn't matter. Again, you see the edit profile. But the difference is that when you click on edit profile, you see that the structure of revolve is given to you. The form and the profile and the axis. And if, for example, I stick the profile to the axis, it will be filled. Inside it will be filled. So now let's see the complete form of it. It's something like that. The point we have here is that in revolve, you can have forms inside each other. Let me use offset. Would you agree? For example, 3 meters. tab, finish. You see that? Let me change the angle for you to see. This is how it looks like. You see that? We can have shapes and forms into each other, but we couldn't have these in extrusion and blend. But a question, what I just drew is somehow like a dome, so we can have different kinds of dome. Now, what better thing do we face when we draw dome in here rather than when we drew dome in model in place? Well, I told you that in maths, whatever we design, we can cover it. Now, for example, were we able to have, for example, a dome with a cover that was made of glass in model in place? Now, for example, I can even load this into project and then cover it with curtain wall. It's a very good benefit. And let's remember that all the surfaces, right, that are, for example, too curved, if they were to be, paneled, they have to be designed with actually mass or in mass because they are paneled. Now, when we move this here, you can see that I can easily use curtain system to cover it. You see that? Now, we can of course change the size. We can change the material of it. Anything. Therefore, let me say that mass has priority over model in big place because it can be covered. And the cover can be, for example, paneled or anything. Let me tell you several points. They're important. Let me set it and then go to elevation. If you design a form with revolve, let me trim this part. Now you want to draw the axis. The point is that you should not design the axis completely based on one of the sides. It will not accept it. So what should we do? You can actually that line that was drawn as the axis must be moved out a bit. Now when you select it, it's okay. So this is one point. It should step out a bit from that side. It should not be completely based on one of the sides. The next point, if your profile is open, for example, something like this. Now you want to draw the axis. Well, when you connect the axis to one of the tips, it thinks that it's one side, it's one shape, and instead of revolving, it uses extrusion. So again, it should step out a bit from that line, so that here we've got two different forms. So it detects it and it revolves. Now, the next point, let me undo. Well, I draw another shape, another form. Let's say I design this, and now I want to revolve it, right? I want to revolve this. I'm designing several forms. I want to have several forms. Let me see if you understand the point. Well, we were about to actually move it out of, one of the sides when we are designing the axis. So when we create form, but when I do that, it shows an error. Why? Well, we did exactly what I told we had to do. So why are we facing an error? That's right. The reason is that the two sides of this profile is on the axis. But back then, we had only one side of it on the axis. So when you have an open form, pay attention. when you have an open profile, right, the axis must step out, must be moved out from two sides, from both sides. You see that? Like that, you see? So that it can create the form. But if the same thing, but if the same thing were closed, it meant that we had a line here too. So now it's a closed shape. Well, it would be okay. You see that? Did you understand the point? There's some slight points that are really important. You see, when this is an open profile, the axis must step out from both sides. But if it's open, it would be enough. If it's closed, it would be enough for it to just step out from one side too. The next point, check these out. Let me draw one here and a semicircle here and close this. Pay attention, it's also very important. Now I want to revolve this. You see that this is an open shape and this is closed. Let me draw the axis because it's closed from one side is enough. But this one has to be from both sides, right? Now, I create the form for this and this one too. Now, do you see any differences? Well, the curve is a bit different, but where do we see it being closed or open? Let me change the angle so that you can see it better. This 100 and this 100 too. You definitely can guess what's happened. Yes, this one has nothing inside it. This one is filled. Now, where do we see the effects of these? Right? The point is that when, right, you have a closed form, when it enters the project, it can have levels, but the other one can just be a shell. So while we are designing the body of a building, it must definitely be closed so that we can select levels for it, right? The other point is that, for example, let's say we design our profile in plan, a rectangle like that. Now, I designed the axis in the elevation, like that. You see that? I want this to rotate based on that. So, create. Now we see that it does not revolve. So we come to a conclusion that for revolve, both axis and profile must be drawn in one work plane. These things we talked about were the points of revolve. Now, based on the information we've gathered so far, we are going to analyze a question, and I want you to respond to that question. Let me see what you do. So the first question, if I have an arc here, right? If I have an arc here and another one here, you see they're in one plane. When I select these two and then click on create form, what will happen? I give you options. The first option, they will be extruded one by one. Option 2, they will be connected and then extruded. Option 3, one of them will rotate around that, it's revolve. Option 4, they will be connected and they will turn into a sheet. What's the answer? Could you find that? That's right. They will be connected. Option 4, and they will create a shell, a sheet, right? Now, let's analyze the options. The first option, we said that they will be extruded separately and one by one, because I told you in maths, the lines you select must create a form together. The second option, they are connected to each other and extruded. It's wrong, because in maths, only one operation can be done. They're either connected or extruded. It's not two. It can't be two. Why isn't it possible for it to be revolved? Because revolve needs a straight line as the axis, but both of these are curved. So when I click on create form, they're just connected to each other. That's it. I don't know if you got that right or not, but let's move on to the next question. When I delete one of these, and then I design a straight line, and then select these two, and then click on create, what will happen? How many forms will we have? That's right, we will have two forms. One of them is the previous one. They will be connected to each other. What's the other form? Because one of them is straight, it can be a revolve. I mean, it can rotate around this, and then we will have a revolve. Because it's two, right? Again, because it's two, we will have an option. We will have two options. It says it can be either a connection or a rotation. You can select both of them. But the third question, if I have a rectangle, let's say a rectangle here, and an arc. Let me delete this. A rectangle with an arc. They're in one plane, right? When I select these two and then click on create, what will happen? Can you think? That's right, I will face an error. Now, why couldn't it revolve? Because it did not have a straight actually profile, and it was curved, and definitely they can't be connected to each other because they're in the same height. But if you give height to one of them, and for example you change it, and then we don't have a level, let me create a level here. So if I change it to level 2, if I move it to level 2 because they're not in the same height, what can they be? They can be connected to each other. That's right, and we've already talked about it. I said that if you have more than one form, all of them must be either closed or actually open. But if you've got two, you're free. It can be anything. The next question, if I design, for example, a straight line in the same plane that we have the rectangle, and then I select both of them and click on create, how many forms will I have? No errors, but how many forms? Just one. That's right. We will have revolve, right? But if I, for example, move this to level 2 and then select it, now tell me how many forms will we have? Can I have revolve again and then have two forms? Because they will be connected, definitely. Will revolve happen too? No. Why? What was the point? I told you that for revolve, axis and profile must be in the same plane. So if I click on create form, only one form will happen, which is connection. That's it. Now, please practice all these examples, analyze the points, and become fluent in designing these so that we can go forward.